Nothing? No homework questions? All right. So our lesson is complex numbers, and it's all the operations that are dealing with complex numbers. So you can see that we have addition, subtraction, multiplying. Where's division? It's not there, but it is there. It's because we really don't divide by complex numbers. We don't divide by imaginary numbers. We actually change them so that they look like something else, and you'll see that at the very end. But to start, letter A, do I have anything multiplying out here? Is there any number out there? No. So I can get rid of those parentheses. So I got 2 plus 3i. I look at this one. It's plus anything going on there? No. So I just go plus 4 plus 5i. Now, take a guess. How do you think you add these numbers up? How what? Combine like terms. That's all it is. All it is. So I just go 2 plus 4 and I get 6. I cross them off once I'm done with them. And then I got 3i plus 5i. So I get plus 8i. Done. Combine like terms. That's it. Letter B. Slightly different. There's one little thing that we have to do before we can actually do the same thing. So if I look out here, there's nothing there. So I'm going to write 12 plus 2i. So it's the exact same thing as the last problem so far. The difference comes from this. This subtraction symbol is like a -1. That -1 has to get distributed to the next two pieces. Now, that is the math way of thinking about it. Non-math way of thinking about it, actually the way I think about this, is that negative is just saying take the opposite. So all it's saying to do is flip those signs. So I'm going to flip -5 to +5. And notice if you go -1 times -5, it gets you the same result. I'm also going to go -1 times -4i, or +4i, and I end up with -4i. But also realize I have +4i, so if I flip the sign, it gives me -4i. Nothing too crazy there. Now it's the exact same thing as letter A. So go ahead and combine your like terms. And so we get 17 minus 2i. What questions do we got for letters A and B? We're going to skip C. We're going to jump straight to letter D. And what I want you to do to start is put a little bar there. And I'm putting that bar there because I'm just choosing to multiply the first two things and leave the last thing for later on. Okay? So when I look at this, I double distribute. You've been doing this for a long time. So I go 1 times 1. And notice I drew a parenthesis right at the start because I still have to multiply whatever's in here by that last thing at the very end. So I got parenthesis 1, multiply the next piece, I get -4i, multiply the -9i and the 1, and lastly, I get 36i squared. Close my parenthesis and put 4 minus 3i. Now I know some of you have the temptation to just go ahead and start distributing. Please never do that. Please never do that. Before you do that, always simplify first. There's a quick solve we do for chapter 3. And every year somebody does this. There's like 3 binomials that are multiplied together. Or we might even put 4 and we multiply them all together. And they multiply, they get this, and they start going, and it just becomes this massive problem. But let's think about this. I can combine some like terms. I can start by combining -4i and 9i. So I'm going to have 1 minus 13i plus 36i squared. Now, I'm actually going to go one step further. Remind me, what is I squared? -1. So I'm actually going to change this. And so if this is -1, I'd have 36 times -1, which is -36. So I'll have 1 minus 36. And so that gives me -35 minus 13i, close the parenthesis, and I multiply that by 4 minus 3i. Now notice, if we started multiplying at the top here, I would have 4 times 1, 4 times -4i, 4 times -9i, 4 times positive 36i squared. That would be 4 terms right there. I'd multiply again, I would end up with 8 things. By simplifying, I have 2 and 2, so I will end up with 4 different terms, which is much nicer to deal with. So now, we double distribute. So you're going to tell me this stuff now. So what is the first thing I get when I multiply those pieces out? Get those calculators going. Type in those numbers. -140. Very nice. No calculator even. -140. Next piece gives us what? I'm going to take the -52. I'm going to tack an I onto it. That's going to be our third term. That's what you would get from the 13i and the 14. What about -35 times -3i? We do end up with 105i. And our last term that we get, so the -13i times -3i. Perfect. So I'm going to do two things now. I'm going to combine my i's, and I'm also going to deal with this 39i squared. So I squared, again, is one number. -1. So I can choose this to instead be 39 times -1, which gives me -39. And so the very last piece is combining those last two things. So I get -179 plus 53i. That's about as long as these problems get. Okay? So that was the hardest one that we would expect you to do. What questions do you have on that one? There's a lot going on.
Where did the 36 come from?
Up here? The 36 came from -9i times -4i. Any other questions? You get to do letter C. Go ahead. But it's not minus negative 25, or not minus 25.
Okay.
It's really close. You're just watch your signs. Watch your signs. So, folks, multiplying this out, I get 1 from negative 1 times negative 1. I multiply again, I get negative 5i. Here I get positive 5i from the negative 5i times negative 1. I multiply to the next and I get negative 25i squared. What happens to the two middle terms? They cancel out, so they're gone. Then I look at this. I squared is what number? Negative 1. What's negative 25 times negative 1? Positive 25. So I get 1 plus 25, leaving me with 26. You don't have to be sorry. You're right there. You had it. Now, think about that. You just took a complex number. What kind of number is that? It's just a real number. Easy number. Sure, we'll call it an easy number. It's a nice number, right? No imaginary. There's nothing there. Okay? Notice the numbers that are up here. We got negative 1, negative 1. We got 5i, we got 5i. The two signs in the middle are the only things that are different between the two of them. Okay? Now, I'm going to make you do some flip-flopping on your page. We're going to skip what you currently have, the conjugate. We're going to come back to it, so don't cross it off or anything. But we are going to go to letter E. Oh, you got this. All right, letter E is not that bad. The thing that it says, though, is imaginary numbers cannot be in the denominator of a fraction. We need to get rid of I. Now, let's just think about I for a minute. Okay? I equals what? Not negative 1, right? I doesn't. I squared is negative 1. What is I? The square root of negative 1. Yeah, the little squiggle of negative 1. So I'm going to write that. Oh, nope. I'm going to write it on the board because otherwise no one's going to see this. So negative 1 equals I squared. Is that an imaginary or a real number? Real number. Not imaginary at all. We actually get rid of the imaginary. But I equals the square root of negative 1. So I want to get rid of this I. What can I multiply by? Add it or do something, some operation. James? Times 3i. Oh, that works. That works. Now I'm gonna make it just a little bit easier. You don't have to times it by 3i. You can times it by just the I. Okay? Because then that will cancel out. So, folks, you can multiply a problem by 1 any day of the week. All the time. Alright? If I have 2x plus 5 and I times this thing by 1, did I change the problem? No. So what we're going to do is we're going to multiply E by 1, but we're also going to multiply by I. So let's watch the magic happen. So I put multiply and I times this by I, but you give me some knowledge here. If I'm dividing by I, what could I put on top here so that it would be 1? I, or what number divided by I is 1? Answer this for me. Answer, we're on to something. We'll come back to that. What divided by 10, is 1? What divided by 5 is 1? So what divided by I is I. So if I multiply the bottom by I have to multiply the top by I. I divided by I is just 1. Okay? I can care less about whatever's in the numerator, what's in the top of the fraction. I don't care. I expect to have I expect to have a nasty fraction, whatever, it doesn't matter. The only thing we care about is getting rid of I from our denominator. So we're multiplying this so that when we multiply, just in the bottom, I get 3I squared. And that's really nice because now I squared, gone. The imaginary number is gone, we just get a -1. So we're going to finish out the bottom, and then I'll tackle whatever you just said. Now on the top, I do want you to put parentheses anytime you see an addition or subtraction symbol, because otherwise we multiply to one of the items but not both. And you got to multiply to both. So this becomes 2I minus 5I squared. I'm going to just finish this off. So this is 2I minus 5 times -1. And I always write the real portion of the number in front of the imaginary. So I'm going to write this as 5 plus 2I.
Does that like matter a lot?
Formatting wise, kind of. They're so new to you, I'm not going to be too much of a stickler on it. I won't take points if you wrote 2I plus 5, but I might be like shaking my fist at you when I'm grading it. Okay? So I'd recommend always doing that, but it's just part of the mathematical language of how we write things. Do we have any questions about all of that process? Anything that happened there? You could multiply by 3I. What happens though, if I multiply this by 3I, down here, I actually have to reduce my fraction. If I multiply this by just I don't have to reduce this. Okay? If we multiply this by 3, you would have 15 plus 6I divided by -9. And then I would have to reduce this and it would give me the same thing. So 3I is fine. If you multiply by 3I, that just gives you 9I squared, right? Which just gives you the -9. And then if you're looking at the top, that still just increases the multiplying. And then it still just gives you this fraction, which then we would reduce.
2 minus 5I divided by 3I, that's what it's saying. So once you multiply by 3I, you cross out denominators and just have
So you're saying multiply up here by 3I?
the whole thing, the whole fraction.
So you're saying do this?
Yeah.
Yep. And so if you end up doing this, that gives you this right there.
The bottom would cancel out.
So you're saying this would cancel out.
You wouldn't have a denominator. It'd be a fraction. All it's saying is 2 minus 5I divided by 3I. So if you multiply by 3I, you should just be left with.
So if I multiply by 3I, that's something mathematically we can't just choose to do this. We can't just introduce and do this. You can't multiply an expression by any number we want because this actually changes it, right? This is not equivalent to what's over there.
Yeah,
But-
you multiply the top by it too, then you wouldn't have a fraction.
Right. If I multiply like this, that cancels that out. But then I'm left with 3I times 1, and I'm right back where I started. We'll come back to this. I'll talk with you about it more. Okay? We'll come back to it. Any other questions? All right. Now I want you to flip back on your page, and we're going to talk about conjugates. So conjugates, you've actually already seen one today. You saw one with the letter C. This is a conjugate. So conjugates are really simple here and kind of a little difficult, but really simple in the fact that notice the numbers 3, 4i, 3, 4i. The only difference is there's a plus sign in one and a minus sign in the other. So I call this your control V function. Okay? I copy it and then I paste it. That's it. The only thing I'm doing is I go back in my function, my expression, and I just delete the sign and change it to whatever the other sign was. So I could have this. I could also have and my conjugate for that is this. I could flip the script and say this is 2 minus 3i, and then my conjugate is going to be 2 plus 3i. So they're the same exact numbers. We really are only just changing the sign that is there. So for letter C, when we multiplied the conjugates together, we got a real number. We're going to multiply this together. All right, and I'm going to do this because I want us to go through it a little quicker. We should also get, a real number. So I get 3 times 3, I get 9. I get 3 times the 4i, so I get 12i. I divide, or I multiply again, so I get negative 12i. And then I go one more time, and I get negative 16i squared. Let's take a look at C. You have it on your paper. The first line for letter C multiplied to something very similar to this. It had 2 numbers. It had I squared at the back. What happened to the 2 middle numbers? We canceled them out. What happens here? We cancel them out. So I cancel here. Now, the last one, or the conjugate, we had negative 25i squared. This time, we have negative 16i squared. What happens with the negative number when you have an I squared attached to it? It becomes a positive. So this is negative 16 times negative 1, or positive 16. So I get 9 plus 16, which gives me 25. Notice, what kind of number do I have? I have a positive and I have a real number. All right? If you notice a pattern in there that you want to use, go for it. I'm not going to show it to you more than I have. But know that if you use the pattern, I'm 100% okay with that. All right? Now, flip back, and we are going to take a look at F and G. All right, letter F. What is the conjugate of 8 plus I? 8 minus I. Yeah, it's just copy and paste. So 8 plus I, copy and paste, change the sign to 8 minus I, and I do that to the top and the bottom. Notice I put parentheses around this when I have addition going on, because I want to make sure I double distribute as I do this. So, some advice, go step by step, but when you're doing each step, when I multiply the top first, make sure the top's done, go back to the bottom, make sure that step's done, and then just keep going back and forth, back and forth. So I start here, and I get 56i. I multiply my next piece, and I get minus 7i squared. If I multiply the bottom out now, I'm going to have 8 times 8, so I get 64. Then I get 8 times negative I, so I get minus 8i. Multiply positive I and 8, and I get plus 8i. Notice these are going to cancel out just like the rest of our conjugates did, so that's a really good thing. And then I have I times negative I, which is negative I squared. So step 1 for the top and the bottom is now done. Go to the next one. So really we're just simplifying here. What do we know negative 7i squared simplifies to? Positive 7. So I'm actually just going to write this as 7 plus 56i. So the top is actually done completely. The bottom, I'm going to cancel the negative 8i and the positive 8i. Gone. So I'm going to have 64 minus I squared, which is negative 1. So I end up with what for my denominator? 65. I add those two things together. So this is going to be the solution, and I put a box around it a little bit before I asked you one question, which is 7 divided by 65. Can I get like a nice fraction from that? And I cannot. So that's why I put the box on already. But we do want to check. We always want to check. I will say, if you can't simplify the first part, just leave it. Normally it works out all right. Okay? But always check the first part. If you can simplify that, then you check the next part and see if you can simplify both. Questions? All right, we have letter G. Tell me what the conjugate is for letter G. 2 plus 3i. And both of these things have addition with them, so I'm going to put parentheses on both of them. And I am going to put 2 plus 3i. And remember, I never care about the top. I never care about what's in the numerator. I only care what's in the denominator, so I'm simplifying that. I'm going to give you about 4 minutes to double distribute and practice this one on your own. So I'll be walking around to check and see how you're doing. All right. So this one. Talk me through what you're thinking. Okay, so going back. What you said. So 5 by 3 I cancel that. Say multiply by 3 I again. But when I do that, really what I'm multiplying is 3i squared. Okay? So for expressions, we can multiply them only. We can always multiply them by 1, but this will be 1. Right? Because I would have to multiply this by 3i squared or 3i squared. How can we do that? So we can only multiply by 1. We can make that as big as 1, but we can't just choose to multiply this. Does that make sense? So you can always, so like 2x plus 3 equals 7. You can always undo things. Okay, so like x minus this by 3 minus this by 3. But really it works because it's on both sides. Okay, so that equation piece is really good. So that works on both sides. Right. Yeah. But no equals. Okay. Yeah. I like the bottom. Let me check the top. Gotta double distribute the top because the top is on top of the keyboard. That's not going to just well. So you get 14. But you also get 21. This one. Like this. That's good. But that's 12i squared. So that's squared. And then you go, gotta have this in parentheses. 214, 7 times 3i.
Whatever.
Yep, you gotta double distribute. So this one we do not have to because there's one more term. This 7 goes to 2 and it goes to 3i. So you multiply both and then you go 4i times 2 and 4i times 3i. It's gonna be 2 more terms. There's not too much more. So you got the first to the last, so you gotta find the middle pieces. Alright. So you're just missing two things. No, that's fine.
Yeah.
I'll go with
Yeah,
that.
13.
You got 8i plus 1i. That should be I squared. So then that's going to give you a nice number. I'm gonna. You're going to. All right. All right, folks. Do not forget that you are double distributing. Okay. So 7 times 2 and then 7 times 3i. Then I got 4i times 2, which gives me 8i. And then I got 4i times 3i, which gives me 12i squared. So that is the top. That fraction is the longest fraction that we've had to deal with. On the bottom, this gives me 4, and then just like the past ones, it's going to have some canceling going on, but I'll get plus 6i, minus 6i, and then minus 9i squared. So the 12i, it's really 12 times negative 1, or just negative 12. So I get 14 minus 12, which gives me 2. So I'm crossing both of those off because I know I'm done with them. Then I got these two pieces, and so I get 29i. On the bottom here, the 6i and the 6i, positive, negative, cancel out, they're gone. Negative 9i squared becomes what? Positive 9i, positive 9. So I just get 4 plus 9, which gives me that 13. Yeah. How are we doing? All right. You have just about a mod to get going on the homework. Please start with whatever you thought was the most confusing so I can help you out with it. And then with the last 5 minutes of class, I will pass back your quizzes. Again, I'm not going to answer questions on the quiz until you actually have it tomorrow. Okay?